next part.
Yeah.
And then maybe at the end, if we have time,
yeah.
we'll do that.
Okay. So
okay. So we're going to talk about doing RESTful services now. So Play makes it easy to define not just things that render HTML, but also things that do RESTful pattern matching and can return JSON or XML. So my turn to drive, right? RESTful service, and now you can make fun of my my coding skills. Okay, so to do that, we've got this list of speakers, and it'd be great for Stefan to be able to review the list of speakers and see all of their proposals. But we want to do this in the new style way with HTML5 and Jquery and Coffeescript. So what I'm going to do is start by creating a new service that then we'll access from Jquery. So to do that, let's add a new route. So I'm going to come in here and do a GET request.
Be careful, it's a Dutch keyboard.
Okay, it's a Dutch keyboard. I'm going to create a new one for, let's do speakers.json. Okay, so if I make a request to speakers.json, I want JSON data. So now let's call controllers.application let's call get speakers.
You know what we forgot to do is to actually redirect. We'll do that later.
Okay. Okay. So now let's go write this method get speakers. It's going to return our list of speakers as JSON. So let's come in here and add a new method here. I'm going to do a public static result. And result.
You see?
There it is.
It's not easier.
Get speakers. And what I'm going to do is get my list of speakers, and then I'm going to serialize them as JSON and return them. So first, let's get our list of speakers. So we'll say list of speakers.
This is where he will say Nicola didn't do a good job because he did not put a finder method.
No finder method? That's okay. We can create one here. So this is going to be equal to a new model.finder, and first argument is going to be the class type of the primary key. The second one is going to be the class type of the entity.
What you will do usually is put this finder method as static on your what is it?
On the speaker
class usually.
Yep. So we could do it that way if we wanted to, and then we're going to call on this finder. There is a should be a find. Oh,
we miss the import for model, I think.
Ah, that's why it's not.
See, Eclipse is really not easy to
I owe
use.
Guillaume so many beers for this. Okay, let's import the model, and now let's call .all. Okay, so now I get my list of speakers, and now I want to return those as serialized JSON. So to do that, let's say return and OK, and then I'm going to use this toJSON method, which we'll import in just a second, and pass it the list of speakers. So let's go get Eclipse to import that. Come on, Eclipse. Does Eclipse know how to import static methods?
No.
No. Oh, I'm an IntelliJ user. I do not. Sorry, what was that? Where is the toJSON? Import play.libs.js capital .to static import.
Yeah.
Static to JSON. There it is. Okay, now let's scroll back down, make sure everything looks good. Okay, it does. Okay, save, and now I should be able to go to the browser and do speakers.json, and hopefully we see. Oh no! Infinite recursion. Oh, that's a bummer. Okay, that's because we're doing eager loading.
Yeah.
Is it?
Yeah.
Oh man. Any suggestions on JSON serialization?
Let's do a lazy loading then. That's fine.
So if we switch this, you think?
Yeah.
Lazy. Let's try that. Reload.
No.
It's not lazy loading. Bummer. Okay, we have it.
What is it? Sorry? Primary key is incorrect. It's longer.
Oh, thank you. Is that going to fix my problem? I don't think that's going to fix my problem, but that's good to know. Oh man. Here's what we're going to do. We're going to go into proposal and take off the speaker reference.
Yeah.
JSON, the fun of serializing data with referenced entities. Okay, this is better. Can I find map property speaker? That's okay. We can fix that.
Yeah.
Let's go back to
the speaker. And yeah.
Okay. Refresh. Come on, show me JSON.
Yeah.
Apply my script. Oh, we don't have speakers. Let's go add one.
Yeah, we need to add one.
Now, did we break the rest of our app?
We'll see. I think it should be okay. Yeah.
All right. We've got a speaker in the database.
Let's see if
Let's
we
go
have
see our JSON. Yeah.
Well done.
Okay, so we've got our JSON now. It has our speaker and that speaker's proposals all serialized as JSON. So that's great. Let's go now and write a little client to consume that JSON on the client side. So from the browser, make a AJAX GET request to get the JSON and then pull it down onto the client. So we're going to create. Let's see. Let's do a new route here.
And if you're wondering why we do that, it's because we do not want Google to index our list of speakers. So we put them dynamically in the...
And we just want to be cool, because all the cool kids are using JSON.
That's true, yeah.
Okay. So let's create our new controller here.
Yeah.
Application.admin. Okay. And then let's go add in here a new public static result for admin. So this is just for Stefan's use. And then we're going to do a new template. So we'll return OK with our new template. So we're going to call that one admin. So it'll be admin.render. And no parameters on this one. Let's go create our template. New file.
Or you can copy one. Because then you have the main.
Good point. Good point. Let's duplicate this one. Paste.
Okay.
Okay. Admin.scala. Okay. Now we do not need any parameters. Yeah. We do want that main. Now let's go.
I'll remove all.
And where's page down on a Mac keyboard?
It's function something.
Okay. So now the fun part. Okay. So I've got my page. Let's just make sure that everything works in my admin here. Let's go hit that. Okay, great. So now we want to render our list of speakers, but we want to do this in the AJAX-y way. So to do that, you could use JavaScript or Coffeescript. I'm going to use Coffeescript, and this is where we'll see the asset compiler in Play 2 coming into play. So literally coming into play. Okay. So what I'm going to do is I'm going to just create a UL. I'll give it an ID of speakers, and then just leave that empty. So this is actually going to fill in using Jquery to modify the DOM when we get the list of speakers back. So let's now have a script that's going to load when this page loads that will then do the fetch. So to do that, let's do a script and set the source equal to, and now I'm going to use the reverse routing, and I'm going to do assets dot, and then what is it? Roots. Sorry, not assets. Roots. Thank you. Roots dot backwards. Not assets, and then
at.
Dot at. There we go. Now I'm going to look for the asset at JavaScripts. index.min.js. So this asset's actually going to be compiled by the asset compiler. So I'll show you how we set that up in just a second, but let's close out that script tag. Okay, so let's go create. Now in the app directory is where I want my compiled client-side assets. So any less CoffeeScript or JavaScript that I want compiled will go into an app and then assets directory and then JavaScript. So let's go create that new package. So this will be assets.javascripts. So CoffeeScript goes into the JavaScript package as well. And then let's come in here and create my new index.coffee. Okay. Has anybody here done any CoffeeScript? Wow. Okay. You guys, a lot of you are going to get to see your first CoffeeScript today. CoffeeScript is like the new hipster way to create JavaScript. It compiles into JavaScript, but it does away with a lot of the nastiness of JavaScript. So a lot of people are beginning to use it to write their client-side JavaScript just because it has some powerful features. It's really just JavaScript at the end of the day, and takes some of the nastiness in JavaScript away. So I'm going to use Jquery to make a GET request to that JSON service. To do that, I start out by having a hook into when the page is loaded. And to do that in Jquery, I set up a function handler that gets called when the page is ready. So that's just in CoffeeScript, the notation for that is have a function that is on the Jquery ready. Okay? And now, what I want to do is make a GET request to /speakers.json. So that's my first parameter there. Actually, I don't need the parentheses around that one. Let's remove that. So the first parameter to this is the URL that I'm going to make the request to. There's a really awesome way in Play 2 to get the reverse routing definitions into JavaScript. I'm not going to show that in this case, but okay. Then the second parameter in this GET function call in Jquery is a callback function that Jquery will call when I've got the data back from making this JSON request, and it's going to be the deserialized data, so the actual objects. So the parameter here is going to be speakers, and then to specify that it's a function, I do that. Okay, so now get my list of speakers from this JSON service, call this function that takes a speaker's parameter, and then what I want to do is iterate through the speakers. So I do a each on my speakers, and then the second parameter is the function that I'm going to call for each of the speakers. So that's going to be take two parameters. The first one is an index. The second one is the actual speaker, and that's a function. So I do my mapper there. Okay. And now what I want to do with each of these speakers is append them into the DOM in the right place. So each speaker I want to add into that UL object that's on the page. So I need to first look up that UL object. So let's find that with, did I call it speakers? I think I did. Switch back here to admin.scala. Yep, speakers. Okay. So in Jquery, to look for something by ID, I use pound and then the ID name. So that will find that UL on the page. And then what I want to do is append onto there a new object. So the new object is going to be a new list item. So I'm going to do $, create a new list item. So in Jquery, I just do that. And don't remember if I don't think I need the parens there.
You don't.
Actually, maybe I do, because I want to now set the text property on that list item. So I'm setting the text to the list item to be the speaker information. So there's going to be speaker.name, and let's say speaker.bio. Let's wrap that in parens. Okay, I think that's going to work. Any problems with that code? A beer is up for grabs. Okay. Okay, let's give it a try. Okay, so one thing to point out real quick is that you'll see that here I did index.min.js. Where does index.min.js come from? Well, the asset compiler is going to automatically create that file by compiling the index.coffee file and then minifying that index.coffee file as well. So the asset compiler will do the compilation. It'll give us any compilers that we may have. So let's go see if I get lucky here. Refresh. And it'll compile the Coffeescript, and there we go. So there's my list item with my speaker name and my speaker bio. So that was making the GET request to the JSON, getting the JSON back as objects, as this array of speakers, iterating through that array of speakers, and then adding each of those to the DOM.
I think they do not believe you.
They don't believe me?
Yeah, add another speaker.
Let's go check out the, how do we pull up the developer tools? Is that over here?
Yeah.
Okay.
No,
tools?
I think
there's some keyboard combination to do it.
it's better to do it like that. Up.
Okay. So yeah, just so that no magic here. Let's do this again so you can see exactly what's happening. So here's the requests that get made. So of course there's the page request 200, and then we load jQuery, and then we load index.min.js. Let's go take a look at index.min.js so you can see what that source code actually looks like. So this is my minified index script that was created from that Coffeescript. So you can see it looks pretty similar to my Coffeescript that I wrote, but now it's JavaScript-ish or JavaScript and minified. Also, we can see that when jQuery is loaded, then we make the call to speakers.json. We can take a look at speakers.json and see here's my JSON objects that I got back, right? And then that's it. Oh, we made a request for a GIF later. Okay, so that worked. Magical, fun. Everybody's going to use Coffeescript for doing their client-side web apps now. So, okay, of course we could have done that in the server-side templating as well, but we just wanted to give you an idea of how we can do this client-server programming in play with talking to our RESTful services. Anything to add?
No, I think that's what we wanted to show. I'm surprised no one is reacting. Do you find it cool?
They're amazed.
Cool?
They're
yeah?
amazed.
I think so.
Too amazed.
Do you find it that it's pretty cool or not at all? Doesn't interest you? Oh.
Yeah.
I think
okay.
we lost them.
We lost them. Your coding's better than mine.
Yeah, I guess.
I'm too fast.
Okay, so let's go back to our slide. I think they're all sleeping actually. 3 hours is really long. Huh?
Do we need to take another break? We got 45 minutes left? Or no? What do you guys want to do? Take a break, thumbs up, or no, take a break, thumbs down? Take a break? Okay, most people are saying no. So, all right, we're going to keep going. We're going to keep going.
HTML5 we did.
Do you, yep, we did that one. Do you want to deploy these changes up on Heroku? Should we do that?
I think that's a good idea because otherwise no one can use that. And
that's right. And we really want, we want Stefan to be able to switch over to this app. So
I don't think they believe you actually.
Yep. Okay.
I think it's all trick. No, he will deploy and you can go on the URL and add your own.
That's right. But don't tell anybody about the admin URL. We haven't secured that yet. So.
Okay, so I'll let you deploy, I guess.
Okay. So to deploy this up on Heroku, now we're using a database in this application. When you create an application on Heroku, it gets a Postgres database by default. It's just a freebie Postgres database. And so we want it to, when we run on Heroku, we want to switch over to the Postgres database. So we have to make a few changes in order for that to happen. So there's one change we need to make is to bring in the Postgres driver. So to do that, we look here in the project directory and then this build.scala file. This is where we specify any other dependencies that our application has in a Play 2 application. So I'm going to add in the dependency now for the Postgres driver. So this is PostgreSQL, and then we use %, so that's the group ID. Then the artifact ID is PostgreSQL as well. And then we specify the version, and this will be 9.0-801.jdbc3.
If you don't have a really good memory, you can just Google.
Yeah, you could of course just go to search.maven.org or whatever and find your dependency stuff. Okay. So that's how we tell SBT that we need this Postgres driver. Okay. Then we need to do a little bit of change to our proc file. So there's a few different ways that we could change the configuration of play when we run on Heroku. One of them is just to specify the configuration changes right here in the proc file. Can you pull up my cheat sheet for that? Okay, so there's a couple different things that we need to specify. First is that we need to specify the database. We need to override the database driver. We'll see that in application.conf, I think it's at the very bottom of that. Sorry. Yeah, my Linux computer is not usable by anyone but me. Okay, so we need to specify to override our db.default.driver. So let's take that, and we're going to, in our proc file, say, all right, set that parameter to org.postgresql.driver. Is that right? Is that the right driver class? Okay. I've got my cheat sheet. So there it is. Okay. Okay. Org.postgresql.driver. Okay, great. Okay, then when Heroku provisions a new Postgres database for us, it sets the connection information in an environment variable. That's the typical way that Heroku manages environmental configuration, is to use environment variables. And so that environment variable, we're going to set to override this db.default.url. So let's go in here and paste in that. And where I'm going to get the environment variable I'm going to get that out of is going to be $database _URL. And then one other thing is when we run on Heroku, I'm just going to tell Play to do the automatic evolutions of the schema, just to apply them automatically. So to do that, I'm going to say apply evolutions equals .default evolutions .default equals true. So this is kind of the easy, hacky way to do this. The right way to do it is to actually run my evolutions manually by doing Heroku run. In the Heroku documentation on the playframework.org site, you can see the right way to do it. But this is the easy way to do it. Okay. So there we go. I think that looks right. Does that all look right?
Yeah.
Okay.
I think so.
So I've got my driver, and I've got my proc file configured to point to the Postgres database to store this data instead of storing it in an in-memory database. So now let's go back to the command line, and I'm going to do my, where am I?
Yeah, this one.
This one. There we go. Go back in here, and how do I?
Tough time. Yeah, should be.
Is it going? Oh, just taking a second to close.
Oh.
Hmm. There it goes. Okay. So let's check my Git status. And you'll see we've made a bunch of changes. I think I can just add all these changes. So let's do git add dot. And then git, let's verify everything looks good. Okay. Now let's git commits -m. Say Stefan ready. Okay. We're ready for Stefan's review. And git push Heroku master. So now, the nice thing about using Git for this as well is that the Git push will just send the deltas. So our Git push should, again, happen very quickly because it's going to have to upload just a little bit. Hopefully the conference network is okay. Yep. Yeah. So we uploaded 35K of changes. And now Heroku is going to rerun the SBT build on this project and then redeploy the slug file out onto the dynos. So again, it'll take a second for SBT to run. Not the fastest build tool on the block, but it'll go, and then we'll be up and running in the browser. So the way that this works on Heroku is that it's not going to actually shut down the old version until it's actually done a successful build. So at the point when it's done a successful build, it'll start shutting down the existing dynos, start bringing up the new dynos, both at the same time. While that's happening, the load balancer will actually hold on to those HTTP requests So the browser will actually be spinning for a user that has a request in progress. The browser will be spinning, and then as soon as the new version is up and running, the load balancer will send the request to the new version, and then of course send the response. So there we go. That build happened much faster than before because we already had all the dependencies. So now it says launching. That's what it's doing. Shutting down the existing version and starting up the new version, and doing it across. Remember, I've got this application running on 5 dynos, so it's going to do that for all 5 dynos. But there we go. Let's go and check out the browser, and we should have our new and sexy version here running on the cloud. So anyone that wants to submit proposals for Devoxx Antwerp, just go to Vivid River 9059, and we'll make sure that Stefan goes in and reviews these proposals. So it's still starting up, but we should be. Oh, we forgot to. What is it? /speakers. We should have done a /git handler, but oh well. All right. So there we go. Our application's now running on the cloud and all sexy. Let me go submit my proposal here. If I can type my own name. Not cool. Okay. Then what should I do a presentation on? On Grails versus Play. Wow. Matt Rabel and I are doing that presentation in Colorado in a month. He's going to be the Grails advocate, and I'm going to be the Play advocate. So we'll see who wins in a month. Okay, we'll let you know. Okay, whatever.
We'll bait
and register me as a speaker, and there we go. So this actually now stored into the database, into the Postgres database. We can of course do the same thing to get the JSON. Let's check out the JSON. There's my JSON still working, and /admin. Remember, don't tell anybody about the admin, but there we go. So that's now the new version of my app running on the cloud. Okay, cool. Thank you. Thank you. Okay, what's next?
I think next is we didn't do any test on this application.
We didn't do any testing. We should probably talk about testing a little bit. Let's see.
Yes, this is testing.
Okay.
So actually, do we really need to do testing? No. So it's type safe anyway, so we don't do testing.
Yeah, we don't need any testing, right? It's all type safe. Our tests are written by the compiler, right? No? We need testing?
Well, if you want, we can do testing. But we'll just show you some example. And for that, we'll invite Guillaume, no, I think.
Guillaume says, what do you want?
Je sais même pas moi-même, donc copie ça, copie cela, et
you want to just copy that test directory?
Okay, let's do that. You see, Guillaume is not coming up. He wants us to work more. Okay, let's do some testing then.
So let's create a new directory here in this app called test.
It's already created.
Oh, is it?
Yeah, should be.
Ah,
It's it.
fantastic. There it is.
Okay, so we need to copy some classes. Can I do that? No.
Eclipse, my test, new classes.
Okay. We probably should have written our test first.
Yeah.
What do you think?
Yeah, I think so as well. Okay, so what we'll do, we'll just be inspired by the example. We'll do a find by. No. The problem is we didn't provision the database, so we will not really help. This one, integration test. So you have 3 types of tests. You have the integration test, the functional test. So functional, it's really integration test is to test like you were in a real browser. Functional tests are tests that to test each functionality of your application, and the model test is a unit test. And you can see that I will not copy and paste and do the test. I think it's better to see the example. Here you have an example of a simple test where this is a computer database. So basically, the application is a form where you input your computer name, etc. And you can see the tests are really, you declare your test, and you find the you define your file, and you say when it's running, I want to fake an application, and I start my test. And when I run the test, I create a new. I want to find a computer with this ID, and
now we get the expert.
to get the expert.
I think he's going to turn it on.
Yes, so that's just standard JUnit test here. So you define JUnit test as you want. You can create basic unit test, but sometimes you will need to run your test in the scope of a running application. Because, for example, you are using a database, and the database plugin is started by your application, right? So you will define the database connection parameter in your application configuration file. You will define the driver to use. So to simulate the database, you will have to simulate a running application. That's why some of the tests are running in a fake application, because we don't want to run a real application to run our test. We want to run a fake application. And this fake application, we can fake any configuration parameter. We don't have to rely on the real application configuration file for this. We can fake any configuration parameter.
And so this is different than Play 1, how Play 1 did tests, is that right?
Yes. In Play 1, yes, most of your tests need to run in an application. So in Play 1, all your tests were running in a real application. In Play 2, this is different. You can run your pure unit test with a running application, and you can run a fake application to simulate your application.
So fake application comes from Play Framework. They provide a fake application.
Yes. It's part of the test framework from Play Framework. So you can, of course, run a fake application, but sometimes you want to really test your application from a browser. And so you can run a test server. Here, we are running a test server. So we really start a server, an HTTP server on this port, the 333. And in this test server, we are starting a fake application. Here we are saying, okay, we don't want to use the default application configuration for the database. I want to force it to an in-memory database. And then we are starting HTML unit, a fake web browser. So it is using Selenium WebDriver, pretty standard stuff. And here we got here in your callback, we give you a test browser instance, and you are in a running application in a running HTTP server. So you can test, load some page, fill form, click on button, analyze the HTML code, do whatever you want. So you have these three kind of tests in Play 2 already built in.
So one of the benefits of this approach over the way that Play 1 did it is now we can actually run these tests in a continuous integration environment, where in Play 1 that was more difficult.
It's way easier to run continuous integration in Play 2.
So we could actually run the tests on this project. Let's go check that out. So we can go into this Play 2 sample app. So if you have Play 2, there's a samples directory, and we can go into the Java one, and then the computer database example. And so now this is just a regular Play app. You can run your Play command against that. We could, of course, do Play run. We can also do Play test. And this will now run the test that we've defined in this project. So that's the test that we were just looking at is what we're running now. So now it's running the integration test, so doing the fake application, and then running the model tests, and then the functional tests.
And in the same way, you can use the tiled run command to ask Play to check every change to your source file, and then recompile in the background. You can use the tiled test command, and so it will check every change in your code, and will run the test in background at every change. So some people like that.
So you can do test-driven development now in Play 2.
Continuous testing.
Continuous testing. Cool. So yeah, so now in this mode, SPT or Play will just sit there and wait for any changes on the file system. When it sees them, it'll rerun the tests. If you go into a file real quick, go just make a quick
test file, for example, here.
So as soon as he saves it, you'll see that Play picked up the change. Now it's recompiling and then rerunning the test. So it's a really easy way.
Yeah.
There we see our test failure, one failure on that on that functional test.
Pretty cool, huh?
Pretty cool.
That's about it. Is there something else to say about test? No. Huh?
No.
Do you want to? We have
Let's show the comment clock.
comment. Yeah, and we'll let.
So we wanted to talk about async and using Comet or WebSockets. This is another huge feature in Play 2, was how it uses futures and async and Comet and WebSockets in a very efficient way. So if you're building applications that have a real-time element to them or things that you'd be doing polling for, now there's a much better way to handle those connections and handle the threads behind those connections in Play 2. You want to give us any more summary about?
Yeah, the main change in Play 2, in this
Play
new
2.
version of Play, we have now a clear focus on all this new real-time, streamed, asynchronous kind of web application. And well, actually, we'll have a conference tomorrow with Sadek. We'll talk mostly about this new feature. So if you are interested by this, you can come and see us. But yeah, this is one of the sample applications. This is a comment log. So the idea is to have this kind of server push event. So here, this is not the most useful sample application, but here the date is computed on the server side, and every 100 milliseconds, the new date is pushed to the client and displayed on every browser. And here, the way Play 2 works, we don't consume one thread or one connection, I mean one thread on the server per browser connected. So here you can connect 10,000 browsers to this Comet clock and it will consume nothing.
So this is the code. I invite you to look at the code on.
Let's take a look real quick at the not that one.
Not that one.
This one. So explain for us what's actually happening here. So we're not returning just a standard response in this one. We're returning this comment thing. What is that comment thing actually then doing?
Yes. Do you want to talk? Oh, Sadek. Sadek, because this is the expert of this kind of stuff.
So please, everyone, welcome Sadek.
Yeah.
Wow!
So as we said, like in Play, like the whole architecture was designed from scratch for doing these kind of scenarios. As James said, with async results, futures, and things for doing commit and stream processing. There is the whole concept that is called iterator and enumerator behind the scene, and this commit thing represents actually a stream. So now when we make a new commit, actually what we are doing is first actually, so what is commit, right? Maybe people don't know what commit is. There is something in HTTP 1.1, a feature in HTTP 1.1 called HTTP chunk, which means like we can send to the browser, we can send chunks instead of waiting for the whole response. And if the browser can understand each of the chunks, it will execute it. Actually, it will show it or execute it, whatever. Now, the trick is, if I send script tags to the browser, each time it gets a script tag, it will execute it. Now, I can use this exact mechanism for sending script tags with messages, and inside the script tag, there will be a callback and a message. And then I can register in that page a callback for that message, and then I will be receiving messages each time that the server pushes, right? This is the trick of doing commit. This way, client side, I will have a stream from the server that is, pushing messages. And then in my JavaScript, I can make a callback on each message, and I can do something with it. So this is the hacky way of doing commit. There are better ways. There are specifications like WebSockets, which is bidirectional, or server-sent events, which is much more proper than the commits thing. But depends on the browser. So modern browsers will support this new stuff. For old browsers, you can get back to HTTP chunking and commit with using the iframe and scripts and the chunked thing.
So this approach would work in most browsers today.
Exactly.
Yeah.
Yes.
Whereas the WebSockets requires the WebSockets API in the browser, which
but the
isn't.
server-sent event is also implemented in most browsers, including in most modern browsers, including Chrome, Safari, and Firefox. And IE, I guess, the last IE also has it. And actually, if you go to, there is a console we did for TypeSafe, the TypeSafe console. Well, actually, this is based on commit together with the server-sent event. So it depends on your browser. It will choose the right protocol and will use it. From the server side, it's exactly the same, actually. It's just you add an adapter for that stream. So this, in this case, we have a stream that will be pushing into. So this stream is generic. Right? It doesn't care about what protocol is it. And then you can take this stream and put it into a commit thing that will just wrap it into these callbacks. And that's exactly what we do here when we do like a new commit, and then we do some callback when connected, and then we can use the clock, which is like yeah. So it's here like we can plug it with anything. We have an API. We can push messages, and now here we use an actor. Because an actor is also it's something interesting to do, like for messaging and being reactive. And now we can send to this actor, and the actor will write to that socket using the right method in the socket, and this will be pushed into through the wire into the client side that will get this thing and will do something with that message.
So in the past, if we wanted to implement this kind of thing, we would have to actually use a thread on the server to hold on to that HTTP connection for the whole time that we wanted to be able to send chunks down to the client. But now, because we're built on top of Netty, which is NIO, and we have potentially Akka or other asynchronous future-based systems, now we can actually take that thread, and when it's not active, actually give the thread back so that someone else can use it, and then only when we want to send a message are we going to get that HTTP thread back and send the message down to the client. So this is how it can be extremely scalable, much more scalable than the like 250 threads that we usually allocate to like a Tomcat server or something.
Absolutely. So actually, I did some tests before. The application I talked about, the TypeSafe console, it was a private thing. You know, I mean, it's for an admin and a system admin that will have like you will have 5 maximum users on it. It's not for public, right? And we all developed all the thing for these 5 users. And at some point, like, oh, this makes sense. Like, it's so cool. Let's try to put it public. And like, what public? We never tested for that. And then, like, I started testing on my Mac, on this machine. I tried like 10,000 sockets, so 10,000 connected clients simultaneously on this poor machine. And actually, it was fine. It ran fine. I mean, the CPU was, I mean, a lot of CPU. But actually, when you don't send any message, everything is cool. There are 10 sockets connected, but nothing's happening. The CPU is down. It's not doing anything until there is a message to push. And that's, there is quite some CPU for pushing to the 10,000 sockets on a small machine. But actually, it worked well, and I left it all the night, and it was 10,000 sockets, nothing like. This is because this is asynchronous. We are not dedicating a thread for each socket. There are sockets connected somewhere, and we are cool. Each time we have something, we have a message, we can use the threads we have to push to all these guys, and then we can sleep back. And actually, the rhythm is very fast here. You are getting around 150 kilobytes per second pushed to every connected socket, which means if you have 10,000, do the math. If you have 10,000 sockets, then you have to multiply it by 150 kilobytes per second. And it's a huge bandwidth. So actually, our problem turned to be not the performance, not the CPU, but rather the bandwidth.
Saturated the I/O.
Yeah, exactly.
Nice.
So
cool. That's awesome. Yeah, so you guys can check out this demo of the TypeSafe console. It's all updated in real time, all, of course, based on Play 2 and Akka. Really cool stuff.
Thank you very much, Sadek,
yeah, that was
for
awesome.
the explanation.
Cool. Great.
Yeah, I think
okay. We have like I think 10 minutes left. How do we get out of presentation mode? How do we get out of presentation mode?
It's a really nice school, but
okay, got it. Just as simple. Okay. Cool. Well, we have 9 minutes left, so we wanted to save some time for questions. Is there anything else we wanted to cover for questions?
I think we okay. Actually, we cover everything we wanted to cover. So.
And we'll push this the latest code up to GitHub as well. So if anybody wants this Call for Papers app, if anybody wants to help us, take it to the next level, so that Stefan would really actually think about using it, that'd be great. Be a fun way to learn Play 2. So we'll push it up there. We should point out the URL again of that. Here it is. Let's pull it, and then how do we do that like cool zoom thing on a Mac?
Control and
There we go. Let's zoom in on that URL. So that's the URL you can get all that code from. GitHub.com/papit/CFP. Okay. Any questions
Any
about
question?
anything at all? Anything play related?
I think they're all tired because 3 hours is really long, actually.
That's a lot of live coding. So,
Yeah.
yeah, understandable. I owe some people beers. I will be good on those. Find me later. Yeah, question.
I got a question about the RESTful shutdown with Heroku. For example, if someone asks for a PDF and it takes like 10 seconds,
Right.
and I put text my code on Heroku, what happens?
Right, yeah, so that's a good question. So the question is, what happens if there's a long-lived request on Heroku? Heroku's load balancer will only allow connections to be open and idle for up to 30 seconds. So if you have a process that takes longer than 30 seconds to handle, there's a few different ways that you can do that. You can kind of send chunks back to the browser and say, hey, I'm still alive, while you're waiting for that thing that's taking longer to come back. That's one way to do it. The right approach, though, is to use Play2's new async stuff and actually, instead of returning the result, return an async result that then could notify the client when that PDF is ready. Play2 has great facilities for doing that. That's the right approach to do it. You don't want to keep those connections open for a long time if you don't have to. So you could have that thing that's actually doing the PDF creation either running on another node, so you could have like a worker node that's processing these background requests, generating PDFs, putting messages on a queue when they're done, which then go through Akka back out to the client using Play2. So that would be a good approach. There's a great example of how to do that that was created by Havoc Pennington from TypeSafe. It's called WebWords. There's an article that goes along with it on the Heroku Dev Center. So send me an email if you can't find out anything, find that information. jw@heroku.com. Did that answer that question? Okay, cool. Other questions? Yeah.
Yeah.
Sorry, I can't hear you. Can you use the Eclipse Debugger with Play2? Yeah, so you just have to, there's two different ways to do it. You can either launch Play from a launch configuration that actually launches the Play server within Eclipse, or you can launch Play with Play debug run, and then that will open up the port that then you can configure Eclipse to connect to the debug port. That's probably the easiest option. Just Play debug run, and then connect Eclipse to that, or IntelliJ up to that debug port. Yeah. Other questions about anything? Okay, wow, we totally wore you guys out. It's totally time for beer or something. Is everybody excited about Play2? Is anyone not excited about Play2? You can tell these guys, they'd love to hear it. Any other questions about anything? Okay, totally overwhelmed.
I think they're waiting for us to say you're free to go.
Yeah, probably. When do we get beer? Is that coming soon?
I don't know.
Is that coming soon?
I don't know, actually.
Okay. All right.
Thank you very much.
Feel free to find us afterwards if you have any other questions. But thank you so much for being here. Hopefully it was useful for you. And I want my bottle cap opener back. All right, thanks.
Thank you.